start my JupyterLab. I have here a kind of example script. The first 3 lines just load some libraries and instantiate ESASky here inside my Jupyter notebook. And there's this nice feature in Lab where you can say new view on the same notebook. Let me expand it a little bit. So now I have my fully functional ESASky here, where I can interact with all the data, explore anything, pull out kind of the papers in this region, everything, but fully controlled from my Python environment. So I can, with this, I can change the field of view. I can go to this galaxy. I can change field of view. Every time I change, there is this command set heaps, where I essentially ask it to change to a heaps. I can either select one of the heaps in ESASky, and here this is the beauty thing. If I have my own collection of fits files and I've done my own heaps, I can call it as well. So I can visualize my own data. And then I'm going to show you later that when I call one of the scripts, one of the heaps that are not from the collection, I get this folder here called user, and that's where I have my own heaps. So you can use this for your own data, right? And I think this.
All you have to do is create these heaps.
You just have to create the heaps, which is a command from this heapsgen wonderful software from CDS. I mean, so we think this allows you to put your data in context with everything else we have in ESASky. Now, so you can do this with all the heaps that are there, and CDS have like this heaps network with 300 such heaps files. I can now, for example, now I'm going to this M16, and now I'm going to show you how can I upload my own catalog. So I have catalog in memory, and then with these commands, I create my test catalog name, right? And I just upload it here. So I've just uploaded a catalog with 3 kind of fake sources. You see them here in red on top of my image. There are more things I can do. Let me go. So I can also do the same thing with CBS files. So if I have like a comma separated values catalog, I can also upload it. And then you see, I mean, you have all the functionality, all the interactivity of ESASky. You have it, but for your own stuff, right? Now I have uploaded a second tab with my sources, which is just a CSV file and 3 positions. But I have all the coordinates here. I can just like I did before, I can interact with this in any way I want. Okay, let me go back to the optical for a moment. Yeah. Because of course this is just the demonstration that of that thing working. Okay, I'll put on the DSS. Go back to optical. Now I can create I can also overlay. I can query Vizier for any table in Vizier or any table anywhere and plot it here. So what I'm doing here is querying the Gaia catalog around certain position. I convert the catalog into an AstroPy table, and then I overload it, pull in the sources. Now there you go. Okay, so now this is sources from the Gaia catalog. Okay, so we just use our own AstroQuery module, fetch these files, put them here. But the nice thing, of course, as I said, is that these images and these catalogs are put in context immediately because I show them on the sky. So I can, for example, say, okay, for this particular science case, whatever it was, I can pull out the papers again, and then I can see from all the bright sources here which one have been published. And then, for example, I can see that particular guy over there, well, no one has published about it. So if it could happen to have any particular property in the Gaia data, I can just consider making a paper about this myself. Okay, I mean, essentially we've just released this. Now I'm going to go to another region. I'm going to show you how to upload footprints. So you might also want to put polygons of any kind in the field of view. So I go to this region. I change the sky to an IRAC wavelength. This is a famous bubble called RCW120. I describe some footprints and I upload them. And then I have the same interactivity as we have with footprints in ESASky. So if I click on one footprint, the corresponding footprint gets highlighted in the table down here, and if I click on the footprint here, it gets highlighted up there. So it's really kind of simple, handy interactions that you cannot do on a plot in Python, right? And we thought it was a neat example of how, you know, how this combining essentially the interactivity and easiness of use of something like ESASky or Aladdin Light with the power of Python. This was potentially interesting. And now let me finish by showing you like an actual science case. So imagine this is an actual paper we wrote, okay? So when I was demo ESASky like a few years ago, I would come to this region, which is called row of Fucus. You probably know about it. And I was pulling out the Gaia catalog. Once I have them, what I can do is to just apply my clustering algorithms to the catalog that came out, and then I just make my own calculations, and then I found out that indeed these are the distribution of parallaxes on this histogram, proper motions in right ascension, proper motions in declination. You see there's some funny structure, and then instead of selecting them by hand, what I do is to use a proper HDB scan in particular, and then I let the algorithm kind of cluster the objects, and this is what I find. I find that there are two clusters. One of them centered in -5, -25, and another one centered at -12, -23 arcseconds per second. So we have here I have my two families of sources in this particular region. And now what I can do is to say, okay, now then show me in the sky where these objects are. So I can pull out the cluster 1, and I put it there with yellow color, and I put the cluster 2 in purple in the same region. So now I'm looking in the sky at the populations that I have in my Python console held apart from their proper motions, and I'm just visualizing with my eyes where they are in the sky. So, of course, I mean, we think this is very exciting because of what it enables, right? It will enable people to do anything, right? It's the combination of easy visualization that you don't need to write millions of lines of code to have, plus the power of Python, where you can put all your reproducible workflows. What we have here is a JavaScript API to ESASky that just controls ESASky. We have a couple of functions built in, which we have released already, and you can actually try this yourself today, right now, if you want. I'm gonna give you the GitHub repo where you can download this. But then we need to add more, so that's why we are showing this to people to get feedback.